Another important objective from the lesson, and really a very valuable skill, is the ability to extract some information from contour maps. You'll see contour maps on TV weathercasts and on weather websites, so it's very helpful to be able to gather some information from them. This is a map of surface temperature at 23Z on Monday, January 6, 2014. So if we do the time conversion, subtract 5 hours to get Eastern Standard Time, that's 1800 hours, or 6 o'clock in the evening, 6 p.m. In the eastern part of the United States. We subtract 8 hours to get the time on the West Coast, to get the Pacific time, and that means it's 3 p.m. Pacific time. So this is a map showing temperature in the late afternoon and early evening across the United States. We can see there was some very, very cold air. There was an outbreak of cold air in the upper Midwest and the Great Lakes. Temperatures were well below zero. We can estimate the actual temperatures pretty much anywhere on the map if you know how to read a contour map. We know from the lesson that these lines are isotherms. They represent lines of constant temperature. And we have to know what our contour interval is in order to interpret the map. Here our contour interval is 5 degrees. We see a 30-degree isotherm here in northern Texas. The contour immediately to its north is 25 degrees. The contour immediately to its south is 35 degrees. So each contour represents a change of 5 degrees compared to the isotherm that it's adjacent to. So based on that, we can find the temperature, or at least estimate it, anywhere on the map. If we picked a spot here in central Ohio where the cursor is, we know that the temperature has to be between -5 degrees and -10 degrees because it falls between those two contours. So it's colder than -5, but it's warmer than -10 in central Ohio. We also can use our knowledge to our advantage to see what the temperature is even when the contours are not labeled. We see this unlabeled contour here in northern Minnesota along the Canadian border, and we know that temperatures along that contour are -20 degrees because our contour interval is 5 degrees. This is the -15 degree contour running through central Minnesota. The next contour representing colder air would be -20 degrees. A point inside that circle would have a temperature lower than -20 degrees but higher than -25 degrees, since no -25 degree contour actually exists on the map in that area. So we can say that it's lower than -20, but we know it has to be higher than -25. Another thing you'll find is that some websites have some strange conventions when it comes to shading contour maps. This particular map, the shading, we'll focus on the shaded areas. They represent wind speeds at about 30,000 feet above the Earth's surface. And the strange thing about the convention on this website is that the shadings repeat themselves. So not all areas shaded in light gray, for example, represent the same range of wind speeds. So knowing the contour interval is, again, the key to being able to interpret the map. On these particular maps, the contour interval is 20 knots, and the shadings start when wind speeds reach 70 knots. So the light gray shading here starts at 70 knots, then the dark gray starts at 90 knots, the white starts at 110 knots, but then the colors repeat themselves. We go back to light gray, but that means 130 knots. Then the transition to dark gray means 150 knots, and the transition back to white is 170 knots. So knowing that, we can find out, or at least estimate, the wind speed at pretty much any point within these shaded areas. If I needed to know the wind speed here, say in central Missouri, I know that it has to be somewhere between 70 knots and 90 knots because it falls between the contours of 70 knots and 90 knots in that light gray shaded area. But if I needed to find out the wind speed here off the east coast of the United States in the white shaded area, I would have to count contours to know what the wind speed is there. We start with the outer light gray shading. We have 70 knots, then 90 knots when we transition to dark gray, 110 knots when we transition to white, 130 knots when we transition back to light gray, then 150 knots and 170 knots when we start the white shading. And since we're inside the white shading, the wind speed is greater than 170 knots, but it's less than 190 knots since there's no contour or shading representing 190 knots.